like a formula or an equation with more than one variable. And so what we do is we can take these equations and we can rearrange them. If I say 4m minus 3n equals 8 and I want you to solve for m, that means I want it to be m by itself equals everything else. Everything has a y in it. So I want to get m alone. All right, so the first thing I do is I look at this and I say, okay, what's going on over here where the m is? Okay, I've got 4m and 3n. I want to get rid of this 3n. I do the same thing as if this was a number 3 by itself. I'm going to add it to both sides. Well, 8 and 3n don't add together because they're not like terms. So I just write them down. Okay. Now, I still don't have m completely by itself. I've got 4m. If this was just a number over here, I would divide both sides by 4. So I do the same thing. Divide both sides by 4. And then just whatever's over here is just whatever's over here. It doesn't have to turn into a specific single number. I'm just rearranging it so that m is by itself. Now, the other way you could look at that is instead of adding and subtracting from both sides, I can pick things up and just move them over. In this case, with I'm trying to solve for n, so I want it to be n equals stuff, right? So I want this n by itself, so I need to get rid of this 6p. If I want to, I can just pick up 6p and stick it over here. But when I do that, if I move from one side to the other, I have to change the sign.
It's like you're subtracting.
Yeah, it's the same as if I was subtracting on both sides, except I just move it. As long as you change the sign when you cross that equal, you're okay. Again, I have a 3 over here, so I want to get rid of that. So I'm dividing by 3. So negative. Okay, here's where it gets a little different. Sorry.
Do you have to do both like separately divided by 3?
Well, if you look at these, so 4 went into 8, but it didn't go into 3, so you just leave it like that. But 3 goes into both 6 and 15, so I'm going to divide them both. So it'll be negative 2p plus 5 equals n. If it doesn't divide, though, you just leave it as like a compound fraction thing, complex fraction. Does that make sense? Okay. Not really? Okay, so the difference between here and here, 8 will divide by 4, but 3 won't. So I just leave it alone. But over here, 6 and 15 both divided by 3, so I actually divided them. Is that better? Okay. This is your final answer. We've rearranged it to where these things are by themselves, and then you're done. Yeah. Yeah, it's just rearranging. We're not. It's called solving for n or solving for m, but we're not getting a specific solution so much as a rearrangement. So if we come back, this one's a little different. I have k minus 2 divided by 5 equals 11. So to get this k by itself, I first have to get rid of the divided by 5. So I'm going to multiply both sides by 5 to cancel those out. So I get k minus 2 equals 55. Then I can add 2 to both sides. Well, that only had one variable in it. That was silly. I must have typed it wrong.
Oh, I thought it was just being smart.
It was meant to have another variable in it, but it's okay. You guys solved it. Cool. Okay, I want to get q by itself. So if this a times q minus 8, I want to get rid of this a first. So I'm going to divide by a. So q minus 8 is equal to 23 over a. And I want to get rid of that 8. So I'm going to add 8 to both sides. Or I can just pick it up and move it. To get q is equal to 23 over a plus 8. It has x's on both sides, and I want to get x by itself. So the first thing I have to do is get both of the x's alone, or both of the terms with x in them on one side. So I'm going to take this 2y and get this away from this 1x over here. So I get 3x is equal to xz plus 5 plus 2y. And I want x to be over, all the x's to be on the same side. So I subtract xz. So I get 3x minus xz is equal to 5 plus 2y. Okay, so here I was moving the 2y's, here I was moving the xz's. I need x alone. So do you remember if I had something like this and I would have distributed in, which would have given me 2x plus xy? Doesn't that look sort of like this?
So we have to divide.
I have to take the x out. So before we would distribute the x in, here I'm going to take the x out. And then once I've done that, to get rid of this 3 minus z, because it's being multiplied, I'm going to divide it by both sides. To where x will equal 5 plus 2y over 3 minus z. Okay, again, I want to move this d over. Do you guys like if I pick it up and move it, or if I subtract it from both sides? Those will cancel. D minus 3d is negative 2d. Okay, this one is actually not the same because I don't have to. I'm going to move the 5c over, so I subtract it from both sides. So you get negative 2d is equal to negative 1 minus 5c. I need that d by itself, so I'm going to divide both sides by negative 2. Now, 1 and 5 don't divide by 2, but see how this is negative, negative, negative? So it's negatives divided by a negative, so it makes them all positive, yeah. I'm going to move this QR over. So I get 6Q minus QR minus 18 is equal to T. I'll add 18 to both sides. To get 6Q minus QR is equal to T plus 18. They both have a Q, so I have to take the Q out. And then I divide both sides by 6 minus R. So I'll get Q is equal to T plus 18 over 6 minus R. Okay, a literal equation is a formula. You guys talk about formulas in science class. Yeah, this is a circumference formula where C is the circumference is equal to 2 times pi times the radius. So the two variables C and R mean specific things. So I want to solve C equals 2 pi R for R. So I want to get rid of 2 pi and divide both sides. On this equation, V is volume, L is length, W is width, H is height. This is how you find the volume of any rectangular, three-dimensional rectangular solid, or like a fish tank. You can find the volume of your fish tank this way. I want to solve it for L. Well, that's V is equal to L times W times H. So to get rid of that, I'm going to divide by WH. So V over W. The way you do dimensional analysis is you set up multiplying fractions. You take the units you're given over 1. That's always the start. So a 10K run is 10 kilometers long. So I take 10 kilometers over 1. That's my first part. I want to use dimensional analysis to find the length of the race in miles. I have kilometers, I want miles. I'm given that a meter is this many yards and this many yards is a mile. So I have conversion factors. These are my conversion factors. But how do I get from kilometers to meters? Do you know how many meters are in a kilometer? So I have 1,000 meters over 1 kilometer. This is my conversion factor, 1,000 to 1. I want meters, I'm trying to get rid of kilometers. This works because one's on top and one's on bottom, so they cancel. So 1,000 meters in 1 kilometer, and then I have 1.0984 yards for 1 meter. My meters will cancel, and now I have yards. And then I want miles. So I have 1 mile over 1, whoa, why'd you do that? 1760 yards. My yards will now cancel, and I'm left with miles. And then I multiply straight across. So 10 times 1,000 times 1.0984. It's 1, 2, 3, 4. 1, 2, 3, 4. So that's 10984. 1 times 1 times 1 times 1760. Then I'm going to divide. Anybody do that in your head? No? Me too.
6.24 miles?
Yep. 6.24 miles. Okay, so we have 100 feet in seconds. So on this one, because we're given 2 units, feet per second, it goes 100 feet over 2.8 seconds. And I'm trying to turn this into miles per hour. So I need to turn the feet into miles and the seconds into hours. So hold on. Conversion factor, right? Miles per hour is 1.4666 feet per second. So if we come back here, 4 with repeating 6s and then a 7. How many 6s is that? Doesn't matter. 1 mile per 1 hour is equal to 1.4 over 1 second. Okay. We went for 2.8 seconds. We went 100 feet. Right? On this one. How many seconds are in an hour? Right, so 2.8 seconds. I've got 60 seconds in an hour, right? So I'm going to take that 60 seconds and divide it by 2.8. That's 60 seconds in a minute. That's what I meant. Okay. 21.42. So actually 3,600 seconds in an hour, huh? That's what I meant. You know what I meant. Extra credit for correcting me. So there's 1,285.7 times in an hour that you would travel 100 feet. Does that make sense? If you take that hour and you break it up into 2.8 second blocks, you get 1,285.7 of them. Each one of those, you go 100 feet. Does that make sense? So I'm going to move the decimal place to, so it's 128,570 feet per hour. Anybody know how many feet are in a mile? 1 mile, 5,280 feet. I think I have. So I divide this by 5,000, what was it, 280? Yeah, that's on the website. So I divide that by 5,280. I've gone 24.35 miles per hour. Now, I did not use dimensional analysis on that. And the reason I did not use dimensional analysis